all sustainable. Lime era also is all sustainable. Cement era, mostly unsustainable. That's it. So this is the fundamental principle of sustainability. Even the IGPC people talk about this one. Reduce, reuse, restore, recycle and replenish the resources. This is the only fundamental that you have to understand to build sustainable. Okay, this, what is it? Reduce means reduce usage of resources, restore, reuse whatever is possible. If you have a old building product, reuse it. Restore the old buildings, don't simply just go and demolish it. Recycle, if other things are not possible, recycle it. And replenish the natural resources. Replenish the natural resources, trees and other vegetations and all that. So sustainability can be achieved only by inclusive sustainable development. It should be inclusive, and also we should also include biodiversity. Biodiversity, inclusive sustainability. Because 40% of the world's population is living, depending on the biodiversity. 40% of the world's economy and 70% of the world's population is depending on their livelihood on natural resources, biodiversity. So trees. We think that what is a tree? It's just not a tree. It has got so many other things. Millions of microorganisms depend on a tree. It's just not simply a tree. And it is not just what you see on top of the soil. Many things work below the soil. They interact. They share things among them. So this is it. Basic. Protect water sources, systems designed to capture, treat and use, carbon neutral infrastructure, food to be locally and sustainably produced, waste to become a resource, okay? And this was a featured house in New York. The area is 96 square feet. Can you imagine 96 square feet house? I will not a client who wants, normally my clients will say a bedroom should be at least 150 square feet. But this is a small, big, cute house, which smaller footprint. So now, next I'll take you to my selected works, and then we'll come back to the technology if we have time. Okay, shall we do that? This is a project. I do work, I'll just introduce myself. I do work with natural materials. Mostly with natural materials. And I don't say that I don't work with concrete. I do work with concrete. But I don't abuse concrete. I use steel, but I don't abuse steel. Okay. This is a residence which I built in '96, made of mud, called Bodhi, and I won some awards and all for it. It is basically the shape is like so. It's quite free flowing, and I didn't want to build it so geometrically because I felt that nature has amazing curves. There's no straight lines in nature, and trees doesn't look cube like a cube. Everything has got that Fibonacci, that formula. If you apply it, you get like this kind of freaked, nice forms where your functions can just flow nicely through the spaces, in the spaces which are meaningful. So this lots of innovation went into this project. The sense that I did my first mud structure with 42 truckloads, and we achieved about 2,500 square feet at half the cost of construction which was prevailing at that time in Kerala. And the roof was done by using very thin ferro cement uh, rib and skin roof. I designed it. In fact, I'll tell you the story. I just take you through the slides and then I give you the story. See, I approached my structural person to do a structural design for me, but he said, I don't know anything about mud, not confident about it. So I can't help you. Then I had to go back and take my old books and study structure. There's no steel, there's no RCC in that arch. It is just mud. The technology I used is called cob. Cob is monolith. Cob is monolith, right? It's you just like pouring concrete. You just not but pouring it, but you make small, blobs of mud, and just throw it together to make a kind of whatever shape you want. So you're not restricted by the use of blocks. Blocks is what you use when you make straight lines. When you design a set square and T-square, it's easy to make, and also to transcribe that onto the side. It is very easy, isn't it? But this is a bit difficult. But it's very enjoyable. It's quite a lot of fun, is it? The roof is ferro cement. It works out such that you find that gable on that side. That is the highest point of the house. So it naturally ventilates and it gives a passive cooling to the house. So it uses stack effect. I hope you have studied stack effect in college. In climatology, you have to study, at least in physics, in schools also you have to study about stack effect, solar chimney effects, all these things we can use it effectively in building. Those spaces are like so. It's all free flowing. So you're not hurt by corners, you're not hurt by straight lines, but you really feel so good when you're inside. And all that small, the artifacts that you find, it is all made with mud. It's not timber, it's not stone. So we can make anything. We can sculpt out things. We can, work out, make a block of mud and have fun with it, sculpt it nicely. If it's not good, just remove it because it's not going to cost you much. Again, reuse the same material and have fun with it. A lot of fun you can have if you really enjoy sculpting or doing work, and it's really see, all those small holes that you find is all positioned in such a way that it transfers heat from every part of the house to this topmost point, that cable that you see on the southern side. So it naturally keeps cooling the house. The airflows, it's ventilated, it is cooled also. So this is a radiating rafter. I call it as rib and skin roof because this ribs and skin, rib, making of rib. I'll show you the next, if you are getting time, I'll show you in the technology of making that. The ribs are cast on the ground. It's just so light that two people can take it up and position it there on the top, and you can just weld it. And so I'll show you the technology, how it is built and all that, but not in this session, but later. Okay, the last part of the section I will show you all this cost-effective and affordable technologies, how I have done it. Some of the, most of the slides are there in that way. That's a roof. When you take from it, mirror the ceiling, it looks so. That's a lamp made with mud. Jalis, you can make jalis with mud. I used to do work with bricks earlier. I was inspired by Baker, Laurie Baker, and used to do jalis with bricks. But I found we can do jalis with mud too. So this kind of things we can work out. It's not costly. It's just 1 day's labor. That's a bedside table, and that's a mud bed made with mud. Okay, bed made with, but of course inside is hollow. That's a secret storage area where you can keep things and you can be safe, because when you're sleeping, nobody's going to come pick you up. And that's that also is the side table, which is made with mud. This is another mud house structure which I made recently. The flooring is oxide. Open to sky shower. Kitchen, basic, all just for a very cost effective and affordable, sustainable house. Privacy yard and all that. He's my client. He's a journalist. There's another mud house which I did. And we'll go fast, because I think, I don't know whether there's any time restriction. Do you have any time restrictions or anything like that? No. Yeah. Privacy walls like so. This house has 3 or 4 privacy walls like that. It's all made with mud. There is no concrete, there is no columns, nothing. And only the white surfaces that you find is the plaster. That is a plaster, cement plaster. It's what you see around. That was meant for lamps. But birds started nesting in that later, recently. That's how you see from the top. That's it's very friendly with the nature surrounding areas. And this is another project which I did. It's OVM, view means sound. It's done in a very sensitive location near Munnar called Marayur. That is a 7-acre property where there is an artist about their studio, and they wanted to build sustainable. They didn't want to hurt anything. They wanted to actually live with everything surrounding. So that's why I came and they approached me, and I was so excited. And I got this designer award, Inside Outside Designer Award for this project, 2008. So it's a very simple, basic, small house, a house with small footprint. A lot of natural rocks around, and I didn't want to disturb any rock. Keep most of them there and build something which is meaningful for them to live inside. So that rock that you find is a good place for taking some time. Munnar is very cold, you can really afford to be outside in the sun because the temperature goes down a bit. and we dug out a small pool, and it became a natural pool. That was the mud used for making the structure, and the rocks, granite, everything that we picked up from the place and just made integrated into the wall systems. They're enjoying. I mean, last week I was there. A bit of changes have happened there. You know, this is it, like making some couple of steps leading to the rock, making some kind of interventions, but not major interventions to go to the top. You can notice that rock that you find is, it was there, and I didn't disturb it. They said we'll use it as a sitting place if you want. And the flooring is mud flooring. You have seen mud flooring? Have you seen Cowden flooring? I'll show you Cowden flooring, what I've done with Cowden flooring also. Mud flooring. This is mud flooring. It's pretty good, you know, very cool. There's nothing, no energy involved. It's all with the doors were done with bamboo, old timber, some fenestrations. Of course, we have put glass inside that because the temperature goes down to -2 and all that, not -2 degrees, up to 2 to 4 degrees. So we have to keep the heat outside, I mean the heat inside. All these rocks and these were worked in the site. Placement of this was actually done based on a couple of drawings and some with detailed drawings. See one rock sitting there that is originally there. It made a good, we had to do it, accommodate it properly, not destroying it, but normally what we do is when we go and start building, what we do is we do a clearing and leveling the site. That does a lot of damage to the environment. We don't care about the biodiversity there. Small pieces, rocks, boulders, you know, this is just picked up from surroundings, but we have to do some work, placement and positioning it such that it works out comes out as a beautiful piece. That's a bed, that's a washroom, this is a bed, mud and waxed. This is, you know what it is. I don't know whether you know what it is. Yeah, it's not the mixer, but instead of mixer, we used to have this one for grinding masala. This is a resort which was featured by BBC. Mud just taken out from the site, and it's pretty large project, 2-storied mud structure, where everything is built with mud. We used bamboo and steel, composite steel, for making the roof, and lighter kind of partitions. The interior works like this, it flows into spaces. Like it's not a boring corridor, but it works like it flows into. That's a lobby. The structural system was done with bamboo and steel. I have to do the structural design myself. So what I want to tell you is that don't ignore structural design. I teach all my interns structural design. All these people, I just teach them, at least they will be able to handle, at least understand the basic principle of structural systems. Because if you want to be creative, you cannot go and sit with your structural engineers who only knows numbers and figures, and they only work with code. They have some codes for design of beams, for IS codes, for design of columns, design of slabs. That's all. If you want to do anything, if you want to freak out, if you want to really freak out, you have to learn structural design. Not the structural design that they teach, but
go deeper into it, understand more about it, and you should be able to freak out the way in which you want to. But it should be safe also. It's a very simple plant. It's a plant which is very available everywhere. Ficus pumila. You have heard about it? Ficus pumila. It's there everywhere. Doesn't require water. That's the rooms, interior of the rooms. Laterite walls and mud mortar. We have used laterite walls. This is a film academy which I did for this. You should be knowing Kirti Suresh. Yeah, for their. It's a studio for them. It's called Revati Kalamandar Film Academy. This this project was done in 2001, and they had some financial difficulties. No, we made the structure, but the roof was not done, and because they had some financial difficulties, we came back to this project in 2011. Nothing happened to the structure also. So in fact, my client is more confident. He has more confidence than me, and he says that nothing is going to happen to a mud structure, even if it is left exposed to rains. We use COP technology for making this. It's a two-storied structure. It has a courtyard inside, which actually is a space where the students learn shooting. This kind of, these are all arches, two arches. The roofing is done with Mangalore tiles, old Mangalore tiles, and the structure is steel. Sarai Tore is a project which I did in Madhya Pradesh. Anyone from Madhya Pradesh? No. Okay. It's close to Khajuraho, about 1 hour drive from Khajuraho. This was done for a wildlife photographer, British wildlife photographer called Joanna. She's artist. Her husband is a tiger conservation scientist. I had to bridge between two areas, bridge a creek, and that was also designed by me. It's just a space frame, and it cost only 1.3 lakhs or something that time, about 2000, maybe 2010 or 11 or something. It was very cost effective, and we use timber as a material too for the surface, and rest is all structured to the steel system. We understood. I went and studied this local architecture, and I wanted to sort of have a cultural continuity with the local architecture and work out something like that. This is the place where I did Cowden Flooring. The veranda is Cowden Flooring, and we got the tribals to do some work of art, like using lime. They made some patterns along the floor. That's it. That's Cowden floor. Have you experienced Cowden floor? It's like carpet, just like this. But you have to use Desi cow, and you have to see that the cows are feeding only on grass. They don't feed on the cattle feed, because cattle feed, of course, they use fish meal and all that, so it smells badly. So if you can get Desi cows, cow dung. It is also used for medicinal purpose. So You render it, but it's a bit laborious. Earlier, people used to do it, as a regular thing. But if you for resorts, they can do it because they had a lot of workers who idle most of the time, so they can engage them to this type of work. Cowden flooring, nice texture, color, and nice feel. It's like in cold weather also you don't feel cold. Okay, it's like a carpet, laid carpet. That's the interior of the room. In fact, we use oxides. I use a lot of oxide colors, mix and match colors to make go differently from the regular kind of using ceramic tiles, or people are bored of that now. We can make beautiful flooring with oxides. Just see this. Notice that the structural system of the roof is done with bamboo. And we also used teak wood poles in some of the cottages. This is a washroom. That's a wet area. So you can do anything, or if you are creative, you can just work out anything. That's for hand scrub. There's also stones placed for foot scrub down. This is the local stones, picked up the local stones and positioned it there. We run totally with solar, 9 kWh solar, that project. And that Banasura runs with 30 kW solar panel, solar energy. That's not air conditioned. This also is not air conditioned. And in this case, because being in Madhya Pradesh, they have to close it down for 3 months. Hottest month. So they close it down. They don't use AC. AC is not. This is a project which happened closer to that. And after seeing that other project, my client is Allahabad based, and they called me. They said there's a lot of huge pile of timber waste and timber and steel waste. He asked me whether I can do it. I was so excited because waste. So anyway, it's not going to hurt anyone. So let's try to do whatever is possible. And that is a kind of simple approach to the design. And that's a fret prone area. So I went in to design something which is very simple, lighter, and very light kind of walls which could be manufactured, this kind of supports, and we could roll it, See, we could roll that. Once you make that, you could roll it, and there's a small fixture by which you could adjust the height to level it, to put the top members. And all this is a kind of detail we work out. Everything is done in the office. Every joinery is worked in the office, so that they don't misuse the design. They have to do exactly as what is mentioned in the drawings. We give mostly 3-dimensional drawings. I'll show you later how we work, what kind of drawings we issue for getting things done in the site. Like so, that's a kind of system. So all the steel and timber that we had, it was documented, and that was put up together. There's also an open sky, a shower area, which I like because it's a very important thing, so that you don't have to go to the hospital to do your vitamin D injections. We can just go there We have an open sky shower area. You can get it freely in the right way. That's a detail of the open to sky shower area. That's a kind of, flooring systems that were designed. Staircase, we make it light. We don't make with concrete because a staircase can be easily made with a simple pipe and supports. Anyway, because we are not going to take the elephants up the steps. So it's only we have to move maximum 150 kilograms, not more than that. Maybe furniture, that also have to be considered. But we can manage with the simple tubular systems. That's a roofing design. Every rafter is designed and measured like this. Everything is set. In my Rajasthan project, we have made the roof on the ground and used a, we just put it up. Crane. We used a crane to just lift it and put it in place. But everything has to be done precisely. That's another cottage. So this is the complete. Oh, somehow this projection system is not working out well, but not seeing what all the details are not there. That's the interior also from here. It looks so lousy in the screen. That's the interior. All this old timber sal, sal? Sal is a very good timber. It doesn't, it's not attractive to, it's not attracted by white ants. So it can be used safely for. See, this is how it was done. It's all timber and joinery was worked out and steel posts. I was photographing that. It's an open sky shower, and we also have made a couple of cottages with local stones, the panna stones. That's how the interiors were worked out. That's a reception. That's a gold painting I was talking to you about. So we encase the local artisans and they also were happy to show off their work. That is a mud structure. That was a cultural center. And there was a restaurant which but original design was only single floor and we made it two-storied later with panna stones. And this deck. Somebody had earlier attempted to do a structure on enclosing the tree. So I used those concrete posts, and we made a deck from based timber and steel, and that deck is now very popular. It's a boozing point. It's a boozing point. Yeah. There's a bar. It's like so. And this water body was also created. I didn't use concrete to do this water body. We used a silpoline. That's a plastic thick piece, with which we lay we shape we form it, then we place it, and then we place stones on top of it. And that's how you don't have to pour in concrete to do this. And what you see on the edges is all stones, local stones, sandstones, that is available locally. There's no concrete required to make such a huge pool. This is not a swimming pool, but it's just a water body. And there's plenty of water down. This project is on the banks of Panna River. That's a deck. This also was done structure. It's an amazing structure. It's about 50 feet cantilevered onto that water front. And I had to do the structure, old steel and strutting it out. And this is a project, 5-star project, which is one of the biggest project I had, the biggest project I could say handled. The resort project, 5-star relax project. I mean, I could do some, I was allowed to do some sustainable solutions in some of the areas, but it has to, we had to do with, we had to use a fair amount of steel and concrete, but wherever it is possible, I could do. Yeah, there was an old structure. There was an old freezing plant left over, which I used as a part of the kitchen, and it was like so when I got the project, and that's how it was made into. Of course, we did a lot of. That was the kind of, that's the area where the pool is there. That was the kind of coastline we had. So it was, I did the landscape and architecture, and basically the concept was to give a journey through the cultural and natural heritage of that region. So I used the local plants. All the plants were picked up locally, personally by me, and we had to look into the Kerala is a place where we had the colonies come. I mean, we had the Portuguese for a long time, the Dutch and the English, and the local kingdom also. So I had to understand the architecture of all these periods and stitch them well, and to make a story so that I could give as a journey through the cultural and natural heritage of that area. That was the whole concept. So this all what you see here is a biofence. That was the boundary edging I gave so that people don't have to come in. People can't go in from here because that's all bougainvillea. It's thorny plants. No, it's naturally a barrier. It makes a barrier, green barrier. So this is how the entire project turned out. And I worked out the cost. I mean, it will take a lot of time if I go into the details of the project. So I will not go into details. That left side that you find, there's a lot of vegetation that is all planted. It took about 10 years from starting to end. So I had a lot of time to do the landscape also. We built we used rocks, natural rocks, laterite, to build hideouts and breeding ground for the fish. The land and the water interface was worked out such that it helps the biodiversity to perform well. A lot of fish come to the shoreline to breed, and lots of fish breed inside cavities. So all these things were considered, and the coastal ecosystem was worked out, and I use mostly natural stones. The rafters is a very traditional implementation of a porch. It's a porch. I mean, it's the corner one is about 29 feet. The rafters, and it's all radiating. So this was a traditional system, which nowadays is very difficult to get something like this implemented. But if we give drawings, certainly we can get it done, because carpenters, we just have to feed the measurements and the scales, everything, and they can do it well. And there's a room below this. This is done with based laterite. Laterite, you know laterite stone? It's what you find in the Western Ghats, right from Konkan region, entire Konkan region, you find this lateritic stone. It's a soft stone, and this is from the waste of that. Basically, it was done. This design was done by using SketchUp, push-pull tool. I used that, and it was cladded with nice small laterite stones. So there is a room. The engineering department worked below this. That's a lobby which connects to the backwaters. So this we wanted the evening sunset to be captured inside. We wanted the reflections inside. So we went in for white, pure white marble. That was a bit expensive. Of course, the project was quite expensive. It came to about 2.3 CR. 230 CR. Not 230 CR. That was the old picture. We transplanted two structures to complete the cultural history of this region. One was a Nayar Tharawad, that's a community called Nayars, and there's a community in Christian. We had to, because it's there in the history of culture, so we transplanted two timber structure from elsewhere, and that was modified to suit today's needs. Oh, this is a construction process. We have 2 floors below the ground and then 2-floor huge multi-purpose hall, and on top of that there's 4 floors. So basically it was quite this is the kind of coastal ecosystems that I was talking to you about, the coastal ecosystems. We use natural stones to build up something like that. So you can see, if you go closer to the shore, you can see movement of the fish and a lot of fun, and you just can enjoy. And some people do angling also, right at the edge. That's a fishing concrete. This is Indian Musanda. That's a landscaping. We use local plants, always. This is Vishnu Kiridam. This is normally not used by. Yeah. That's the stag orchid. Even this paving was done with laterite stone here. Yeah, this is a restoration project I would like to show you. I was just telling you about not to throw away old buildings. You can tweak it. You can make something interesting out of it. This is a 300-year-old Ettigetta, means it's a 2-courtyard house, ancient house in central Kerala, and they came up whether they could make it livable, just like so. Just take a look at that. This is one of the courtyard, and they had problems. One problem was that they can't install a fan because the ceiling is too low. Earlier it was like so. So if you install a fan, you can't raise your hand. So the building height was less. The next problem was that it is so leaky. The roof is tight. So nowadays, you don't have people with good knowledge to handle tile roof. Because it's a leak. If somebody goes up, he'll break more tiles. Earlier people knew how to crawl on top of the tiles. So that is one of the problem. Then next problem was they didn't have washrooms inside. Earlier, people never used to go into the washroom. There was no washrooms in our old houses. You know that. Just either people used to go to the yards outside, or there's not a no washroom concept at all. And for taking bath, people used to go to the pond. Okay, so we had to add washrooms. Kitchen was also very bad, like old firewood kitchen. Of course, that had to be modernized. Then other problems were like small rooms. Small rooms. They wanted larger rooms, so they were. There were so many small rooms because there were joint family kind of thing. You know, those days we used to have joint family and so many small rooms. And that we had to make it bigger. That kind of small problems. So, sorry. That's the second courtyard. They had masonry structure and timber structure. This is how the kitchen was. So we documented the whole structure by using, this 3D. We made all the things in 3D and made the changes as what we want. Added the washrooms, like this point, these two are washrooms which are sitting outside, and we made a washroom inside also. And added some nice privacy walls all around, and extended the veranda, and put timber columns instead of steel. So to solve the problem of the leaky roof, I use a multi-layered roofing system, which I'll explain to you later if I get time. This is a GA. We pull out the tile roof, mango tile outside, and we remove the reapers, put GA sheet, and put back the reapers and put the tiles on top of it. So that becomes leak proof. You don't have to worry much about a tile roof after that. That's how we do it. It's a graphics of that. So to increase the height, I had about 60 jacks. I do lifting also, lifting of houses, little bit, 1 feet, 2 feet and all that. All this heritage properties, we had to jack it at times. So 60 jacks were used. And in timber houses, we have a beam which runs as a base beam, which holds the whole load onto it. It's not transferred to a stone foundation. There's no foundation as such. You can see, it's just mud. That is what is the foundation of an ancient structure, which stood comfortably for 300 years. Why? So building doesn't require foundation because it was so light. You are wasting a lot of resources to build foundations. I'll come to that later. This is how we did it. We just put the jacks in various locations and lifted it. And use bricks to increase the height. After removing the tiles and the reapers on that. See, just like that. The masonry part, what we did is that we put the jacks there and lifted the wall plates. Okay. So the doors became so, it was, we had to redo the doors. We had to extend it down and improve the accessibility. We had to work with all the doors and cut that base beam and all that. So the columns naturally will fall out, when you lift the house. So the columns, we use this structure.
tied the columns onto the wall plate. I had to be there during the lifting process because that's the time when we have to be there careful because people shouldn't freak out. It has to be done very carefully. But lifting takes only about 1 or 2 hours maximum. That's all. That sheet, GA sheet is fixed. That's a final product. Veranda, extended veranda with columns, with oxide flooring. That's one of the northern side veranda. We put larger windows to bring in more light. The interior, this is a changed interior with oxides. That is how it was, and this is how we made that white portion that you see below the column is masonry. That height that we increased down below. That's the second courtyard. I showed you the second courtyard. It was like this. It's the second courtyard, but it was actually we put the dining there, and the kitchen is on the side. That is also open to the courtyard. You can see the kitchen, it's open. And we removed certain panels to make the sizes bigger and make some nice spaces for sitting. And those fenestrations were added onto the door. A lot of fenestrations were added so that it ventilates properly. Of course, this is a courtyard house, but to allow passive cooling, we need some inlets. So for that, we and the interiors of the house was dealt, not making huge change, but to make a proper, style suitable for a heritage property. That's a kitchen, modest kitchen, not very expensive, but basic. It does the job. Just like so. And washrooms. And this is the washroom which is again open to sky. That's a hit. I mean, everyone likes that. Everyone likes to go for a shower here. And you can have rain, you can have a rain shower also. It rains. Naturally, you can have a rain shower. And you can have sun bath. This project is just happening. I am just to show you the type of drawings that we make. This is the kind of drawings that we make for getting our work done. Okay. A lot of other one was just my projects, but this one is more on to how you can really work. This if you are comfortable under a tree near your house, you should be comfortable inside your house. That is my simple, straightforward requirement for any good architecture. If you are comfortable under a tree near your house, and if you are not comfortable inside your house, the design of the house is not done well. Your architect has not done a good job. So we finished the project. So I'll talk about the alternate foundations and basements that we can adopt. This is a slide which I took when we demolished an old structure. See, in most of the part of the country, we had
amazing building materials. In the Western Ghats, we have laterite. Laterite is not a very hard stone and it is pretty soft. And earlier, people used to use lime as a mortar for those laterite stones. And after its life cycle, we could recover most of the stones for reusing it. So once when the building's life is over, we could reuse it comfortably. And it was a great thing. But nowadays what we do, we use laterite and we use cement mortar. Okay. Cement mortar, if you use cement mortar, you are losing the stone forever. You cannot recover it after its life cycle. If you try to recover that stone, you won't be able to do that because laterite is not hard. It just disintegrates. Okay. The graphics is not good. I just want to tell you about the technology that we use now for building a structure. See, all the structure that we design nowadays, you all know what we are, how to do a foundation. What is the system of foundation that we follow in the college? We dig about 3 feet down, minimum, generally 3 feet wide. We make a pit and we make a PCC, plain cement concrete. Plain cement concrete, that is one bag of cement, 148 is the mix that is given, isn't it? For PCC, 1 bag of cement, 4 bags of river sand, and 8 bags of broken stones. You have a session here? Okay, so I'm done with it. So, okay, I'll just explain the structural system that we use and then we can stop it. Okay, just first. Then the foundation, what is the foundation made of? It is stones and cement mortar. Cement mortar is got 1 bag of cement and 8 bags of sand, river sand. And the walls, foundation and basement is done like so. And the walls are done with what? Some places they use bricks. Again mortar, 1 bag of cement and 6 or 7 bags of sand. And what is the roof that we give? Concrete. Isn't it? That also requires a lot of sand and broken stones and resources like so. But what if you take a profile of a old structure, what is the foundation made of? You have any idea? It's just a pit and some local stones and mud concrete. Mud and it is just consolidated. You don't have concrete, you don't have sand, you don't have cement. Foundation is like so, and the walls are done with local stones or mud walls. And what is the roof also is done with? Very light material. Okay, very light roofing systems, tiles or thatch or sheets or whatever it is, shingles or whatever it is like. But you have a structure ready for you with all these local materials. Why are we making such a strong foundation, strong superstructure, and a strong roof? It is because we have taken a decision we need a concrete roof. That is why we have to go for a heavy foundation, heavy superstructure and all that. So, I'll make it fast. If you want to make your building sustainable, cost effective, you can take a decision on the roof. You make a lighter roof, very light roof, so that you can go for a lighter wall, lighter foundation. You don't even have to have foundation like what I showed you earlier. You can even do with a mud concrete or mud foundation. It is possible. So that is the fundamental idea of building a structure. Make it as light as possible. If you can remove concrete as a roofing material, then you have lots of traditional solutions to build a superstructure, build a structure.